Hey everyone, today I'm excited to share a project with you that me and my friends have been working on. We have developed a simple yet effective object detection system using SST MobileNet and OpenCV. In this video, I'll walk you through our project discussing how we use SST MobileNet and OpenCV to build a basic yet functional object detection system. So let's dive in and learn the process behind creating this practical application of computer vision. So let's get started. Object detection is a crucial task in computer vision and deep learning. It involves identifying and locating objects in images or videos with high accuracy. State-of-the-art algorithms and models enable complex scenarios to be accurately analyzed, making it fundamental technology in various domains. Real-time object detection is vast, vibrant, and complex area of computer vision. If there is a single object to be detected in an image, it is known as image location. And if there are multiple objects in the image, then it is object detection. This detects the semantic objects of a class in digital images and videos. So what's deep learning? Deep learning has demonstrated exceptional performance in object detection tasks surpassing traditional methods. Convolutional neural networks have proven effectively in automatically learning discriminative features leading to improved accuracy and generalization. Complex neural networks. Deep learning is a subset of machine learning using complex neural networks. High-level abstraction. It involves learning data representations through a hierarchy of concepts. Automated feature extraction. Deep learning algorithms automatically learn features from the data. An overview of deep learning algorithms for object detection. Region-based convolutional neural networks (RCNN) utilizes region proposals to identify objects within an image. Single-shot multi-box detector (SSD) efficiently predicts and locates objects with single forward pass. You only look once YOLO, which is a very popular object detection algorithm, divides image into grid cells to directly predict bounding boxes and class probabilities.
Popular deep learning frameworks for object detection. There are three types: TensorFlow, PyTorch, and OpenCV. First, coming to TensorFlow, a widely used open source framework for deep learning. It offers extensive support and resources for object detection models. Next is PyTorch. It is known for its flexible and intuitive design, favored by researchers and developers for object detection tasks. Next is the OpenCV, a popular library with tools for real-time computer vision, including object detection using deep learning algorithms. Preparing data for object detection using deep learning. Data annotating images with bounding boxes or polygons around the objects. As you can see the image given in the to your right side, it has a feature extractor and a classifier. Labeling images with classes for classification tasks helps for object detection here. Next is training a deep learning model for object detection. How do we train a model? Data preparation. First we collect the labeled training images for object detection, and next is model configuration. Select a deep learning architecture suitable for the object detection. Next is a training process. We train the model on the labeled dataset to learn to detect objects. Evaluating the performance of an object detection model. Data evaluation. Assessing quality and quantity of training data. Model performance. Computational efficiency considering inference speed and resource usage. An image of an object detection model output showing the detection of various objects in a scene with bounding boxes around the detected objects. The image should convey the precision and accuracy of the detection with clear visuals indicating or successful identification.
Yeah, now let us discuss about the developing a real-time object detector. For developing a true-time object detector using deep learning and OpenCV, we would like to access our webcam during a really effective way. Then the thing detection is to be applied to each and every frame. We should always install OpenCV in our systems, and the deep neural network model should be installed. Firstly, we should always import all the specified packages such as import CV2, that is OpenCV, and the import numpy as NP, and import time. These are the some of the package that should be imported in in the starting of the real-time object detection. Now, then the SSD mobile net architecture is employed as the pre-trained model. This model strikes a balance between accuracy and efficiency, making it suitable for real-time object detection. The CV2.DNN detection model is used to load the SSD mobile net model with specified configuration such as input size, scale, mean values, and swapping color channels. You can look here the CV2.DNN detection model which specifies the SSD mobile net model where it imports the some of the input size that varies from 320 to 320, that is width of 320 and the height of 320, and the input scale and the input mean and swapping color channels. Some of the values of the all the input size, scale, mean values and the swapping color channels has to be mentioned in the SSD mobile net model. Then we have to then the detector class initializes the object detection model and sets up parameters. The class constructor initialize takes a video and model related path as input and set up the necessary components, where we are going to initialize the detector, where we are going to import the video path, configure path, model path and the classes and the log path also. A loop processes each frame of the input video for object detection. The detect method applies the SSD mobile net model to the current frame, yielding class labels, IDs, confidence scores and bounding box coordinates, where we are going to read the success. Upon the success, we are going to read the image. From the image, we are going to read the class labels, confidence boxes, and upon reading the image with the successful communication with the image, we are going to detect the image with the threshold frequency of 0.4. After uh, after the successful image detection, the detected objects are visualized on the video frame and a log is created with respect to time. Time steps are added to create a log for a detected objects, including class labels and confidence scores, where the frame time is applied with respect to the year, month, date, and the hour, minute, second format. And the frame info is also mentioned with respect to the detected objects. The coding maintains a set of overall detected objects throughout the video, logging it separately. For a summary, objects detected in each frame are added to a set, providing an overall summary of object detected objects, where the class label has been initialized for the overall objects detected in the real-time object detection. Now let us take an example on the real-time object detection, where we can see here in the first video frame the some of the objects have been detected, where the bus, traffic lights and the persons and the handbag has been detected from the OpenCV and the SSD mobile net, with the some of the coco names are being trained by the SSD mobile net, where in the output we can see that the object detection using deep learning with the time frame have been listed the with respect to the seconds, where the detected objects can be bus, car, person, traffic lights and some of the bag can be listed according to the timestamp. And the finally the overall detected objects also has also been labeled here, that the bicycle, person, traffic light and the car, handbag, some of the detected objects have been listed at the final output. So this is the example of the video frame 1. Now we can see the video frame 2, where the video frame of the office has been displayed, where the some of the person and the chair, bicycle, laptop and some of the potted plants have been detected from the video frame 2. With respect to the timestamp, we can listed here the object detection using deep learning with the detector objects, cup, laptop and some of the potted plants have been listed according to the timestamp with respect to the each second. And finally the overall detected objects from the video frame 2 also have been listed, that is cell phone, some of the cup, laptop, bicycle and some of the person, potted plants, some of the table have been listed here. So this is basically basic object detection. So this is about the real-time object detection. Fine-tuning a pre-trained model object detection model. Understanding pre-trained models. Pre-trained models are already trained on vast data sets, making them a valuable starting point for object detection tasks. Customizing for specific objects. Fine-tuning allows adjusting the pre-trained model to detect specific objects by learning from a smaller domain-specific dataset. Transfer learning benefits. Transfer learning from a pre-trained model reduces training time and data requirements, accelerating model development. Optimizing for accuracy. Fine-tuning aims to improve the model's precision and recall for targeted objects. Challenges and limitations of object detection using deep learning. One challenge in object detection with deep learning is the need for large amounts of labeled training data, which can be time consuming and costly to acquire. Additionally, deep learning models may struggle with detecting objects in complex or cluttered scenes, leading to lower accuracy in real world scenarios. Furthermore, optimizing deep learning models for real time development on edge devices presents significant technical challenges due to computational and memory constraints. Conclusion and future directions. Improved model performance. Implementing advanced algorithms for better accuracy. Real time object detection. Developing models for instantaneous identification of objects. Robustness and adaptability. Enhancing models to detect objects in diverse environments. As the field of object detection uses deep learning continues to evolve, the focus will be on enhancing model performance, enabling real time detection, and ensuring robustness and adaptability in various scenarios. The future direction will also involve exploring the potential of incorporating AI to automate the annotation process and further refining the training models for most efficient model deployment. Thank you everyone for watching this video. I hope you like and share this video. Thank you.